Hello, my name is Champ Clark. As said, I've been the CTO at Quadrant Information Security. I came to SuriCon in 2016 and was so impressed that I had to come back and hang out with you guys again. It's a really great community. We are based out of Jacksonville, Florida. We're primarily a MSSP. We use Suricata for our backend. We were big Snort users back in the day, and then have been gradually moving over to Suricata. We actually like it so much that in a lot of ways that we watch the development in Suricata and then usually latch on, steal ideas and whatnot, because there's some really cool, interesting stuff that's being done. So again, what is Sagan? Sagan is a log analysis engine. This year, we'll process for just this year about 1 trillion logs through our system. That's across all of our clients. We do a lot of different verticals, everything from healthcare to retail to all kinds of different verticals. As I said, we try to mimic a lot of the functionality that we see in things like Suricata, just because a lot of it's so useful. And then we can also use that type of functionality to cross-reference data. So for instance, we wrote Sagan back in 2009 as a means for us to analyze logs, but we treat logs very similar to how Suricata treats packets, and that there's some really great tools like Splunk and Elk Stack and Logarithm or whatever it might be, but those don't really scale very well across a security operations center like ours, where we have lots of different sensors out in the field. And so this tool isn't actually meant to replace things like Splunk or whatnot. It's meant as kind of an early warning kind of system. So if you think about it, the similar projects are probably like OSSEC and stuff like that. Yeah. So we have a lot of common traits with Suricata. It's even become more so over time. It's a multi-threaded engine. We actually have a kind of a hybrid threading that we do. We use it not only for processing power, but for high latency requests, for instance. The rule syntax, if you already know how to write rules in Suricata, then you already know how to write them in Sagan as well. And the idea here is that we didn't want to have to retrain our staff on different types of rule writing syntaxes. So we adopted a very Snort-like or Suricata-like syntax. And that makes it easy. And same thing with like the back end as well. We store data in very similar ways. And that's also from a correlation standpoint, which helps. So we can do things like output in the JSON or E format. And we adopted things like the YAML format. And we have full IPv6 support and whatnot. As I said, some of the differences that are apparent in Sagan is the threading model, for instance. As I said, so we actually spin up quite a lot of threads at any given time. It's not just for processing. It might be to do things, for instance, like an Intel lookup that requires hitting a file or looking through memory, or even making an HTTP request to a threat Intel database or whatnot. Since we're dealing with logs, we have to add in some rule keywords or rule options that aren't available in things like Suricata. And the reason is just because of the nature of the data that we're dealing with. So we add in things like these things like meta content and whatnot. We also store all of our data into memory map files, which we store onto a RAM drive, which I'll go into a little bit more in a little while. But it helps us with things like process restarts and stuff like that. The basic overall operation of Sagan is that it receives data through a FIFO, or named pipe. This is typically fed to us by our organization. We use a lot of syslog-ng. So syslog-ng receives the log and then spits it into a FIFO, into a JSON format or whatnot. It could really be used for any kind of log data. I'm just explaining how we use it. So the log data gets inputted from a daemon like syslog-ng, or could be very well Suricata if you wanted to, into the name pipe. And Sagan gets it out of the other side of that. When Sagan receives the log via the pipe, that log line gets that message gets assigned to a particular thread, which then goes through the Sagan rule set and applies the logic to there. Then we rinse and repeat, and we do that a whole lot. So at the beginning, if you start looking at Sagan rule sets, they actually look a lot like Suricata rule sets, as you can see. But we actually have a few key modifiers, and they're down here at the bottom. So we have things like, in syslog, you have access to the program that's created in the event. So we add in things like programs, so that we can say if the content matches, but in the program is set to this, then have such and such happen. This is either way to shortcut or short circuit, so we don't even make it to the content portion. We can just check to see if the program's what we need. And we have things like XBits. We use a lot of XBits in Sagan. It was actually a concept that I had read about online, and then the SuriCata team did it. So we kind of did it, you guys did it your way, and then we're actually going to probably adopt the way SuriCata handles XBits. But we had created our method of creating XBits in our own little world without talking to anybody. We also have things like after, which works a lot like thresholding. So this is like after you've seen this X number of times, do this certain thing. And then we have things like the normalize rule keyword, which basically means we take to normalize data. We have several different ways to do it, but we lean on projects like our syslog, who has a library called liblognorm, and it's kind of a masking type of system to normalize data to extract things like usernames, MAC addresses, IP addresses, and stuff like that. But then we also have other ways to do it. So if normalize fails, then you'll see under there's like parse source IP, which basically just rips through the log line and looks for anything that looks like IPv6 or IPv4 IP addresses. That'll give you some of the idea of some of the differences. We have this fairly well documented. We're still working on our documentation. But we also have some things, for instance, if we want to track certain types of events by location. So for instance, I have a SSH connection here that I want to watch for. I'm actually tracking it by the country code. In this particular part in the Sagan YAML file, we actually define a variable called home country, and then you put in the country codes that you want to see in there. So the idea here is that if this trips off and it is not, you'll see in the country code tracked by source, is not in my home country, then I want to generate an alert on that. And we have things like ATOS groups. I'm just kind of going over just some of the real quick functionality that we use. And what this allows is you specify things like times. Like during the day, this would be a normal operation, but maybe during the middle of the night, it wouldn't be, or maybe on the weekends or whatnot. So you can create rules that are basically saying if this type of event happens at an odd hours, we want to see an alert from that as well. And as I said, we can reach into several different types of Intel databases. Do you guys use Critical Stack or the Bro Intel stuff at all? Critical Stack is a kind of it's a site where they gather lots of different threat feeds and they put them into one big collection that you can sign up, download for free and whatnot. And it uses the Bro Intel format. So we can actually use that data to pull it in to say if we see this particular VPN login and it's coming from a known bad IP address, that we can trigger off of it as well. So that's the idea there. So we have a lot of different ways that we can go about tying events together and whatnot. We also have a concept called metadata, or meta content, I should say. This was just something that we added. Makes it easier for the rule writers, instead of having to write 4 rules, to be able to write 1 rule to deal with 4 different types of conditions. So in the very top up here in our Sagan YAML, we actually define a variable called usernames, and just get Bob, Frank, Mary, and David. And then with meta content, it says login, you'll see the % Sagan %, and that % Sagan % is a placeholder for what we have in our usernames variable. So we're looking for login Bob, login Mary, login Frank, login David, and whatnot. So that we don't have to create 4 distinct rules. And then actually in some ways, in the way it's engineered, it actually ends up being slightly more efficient that way. So that's kind of how the rule sets work. As I said, I wasn't going to go deep dive on any kind of rule sets. I got a bunch of people here who obviously write lots and lots of rules. But one other thing I want to talk about is Sagan as an island. So when we started developing Sagan, we noticed that we would end up running not just one Sagan on one machine to read all logs. What we'd like to do is split it up. So we'd have one Sagan process that would be analyzing Windows logs, and we have another Sagan process that was analyzing network logs. And for the most part, they're in their own separate worlds. So that while the threads could share information, so the network Sagan process threads could share information within it, and the Windows could share information with it, they couldn't communicate with each other. So we saw this as kind of a barrier. So on one machine you had two different islands basically within the process space. So what we decided to do is use memory map files, which we store in dev SHM, which is basically a RAM drive. And that the reason that we store it over there is for a couple of reasons. One, for instance, if there's a page fault where it needs to have access to certain types of memory, we don't want to really have that on disk and having to pull that off. So we store it over there. We gain a couple of things by doing this. For instance, now our Sagan Windows and Sagan network traffic, say my network might be Cisco or routers or Citrix equipment, and my Windows servers can now share information. This basically means that if we have a Windows event happen and it sets an X bit, let's say, and later on, we'll just back it up a little bit. Let's say we see a brute force and it's on the network side. It's an SSH brute force. It's unsuccessful. It didn't do anything, but we set an X bit on it, and we actually call the X bit brute force. On the Windows side, whenever we see an RDP session, we can actually check to see if that session has an X bit associated with it. So we can say, okay, we have an RDP session. If the RDP session is successful and has an X, and the source is related to this particular X bit, a brute force X bit, then we want to fire off on that, because there might be a valid reason why somebody might try their password 10,000 times and then be validly logged in over here. But it's something that we'll definitely want to look into. So at this point, we considered Sagan the island just slightly bigger. That is, we went from where it was two processes on a machine that can communicate with each other, so we made kind of an IPC mechanism for them to share information, mostly X bits. And the other great factor on this is that means that whenever you stop Sagan and then restart it, it remembers where it left off. So if you have any thresholding or you have any X bits or whatnot that are set, and they'll be set on the next time you run. This is important to us because our job, part of our job at where we work, is to assist our SOC, and this creates less noise. So if we have to do a rule push and saying it's restarted or whatever might happen, or we just want to manually restart it, we don't end up flooding the console with a bunch of garbage. It actually remembers all that data in there and whatnot. So that's kind of an extra added on benefit on top of that. What we've recently gotten into, and this is kind of beta, is actually having Sagan store X bits directly into Redis. Now, remember I said our threading model is a kind of a hybrid. It's a lot different. As I said, we spin up a lot of different types of, a lot of threads, a lot of doing main processing and whatnot, but we can have a thread spin for a little while. What this basically means is if I need to, I can have a thread gotten right out X bit, which actually costs almost nothing, but to read it might take a little bit of time. But unlike what you guys are doing when the SuriCata world, where its time is critical, we can actually wait a little while and do lookups that way. This makes our island even larger. Now it's the size of the network. And again, this is still fairly beta. We're still testing it. But the idea here is that if we see somebody in Japan and they're doing a brute force attack, we can set an X bit, and then we store that information into our Redis database. Guy is attacking this machine in Japan. Then later on, if we see something else that's related to it in, say, Canada or the United States, then we can apply that X bit across the platform, across the network. So we can say, that's interesting, this guy was doing some shady stuff in Japan, and now he's doing some stuff over here in the United States where he's validly logging in or whatnot. So that's what I mean whenever I say making the island slightly bigger. One question that we get a lot of is, do you have, for instance, the right rules loaded? Just like with SuriCata, what we find is if you have a lot of rules that are loaded that never fire because it's just not set up for your environment, like that type of traffic isn't in there or whatnot, you end up using a lot more CPU. Useless rules use more CPU. But on the flip side of that, if you don't have rules loaded, obviously, then you don't see certain types of events. And we have a ton of rules. So we have everything from, being able to monitor like Cisco ASAs to Windows servers and all types of different types of stuff to AS400 logs and whatnot. And we really like writing rules a lot. So we have a lot of different rules. But the question is, when do you turn some on and when do you turn some off? So we developed some mechanisms that kind of help us answer those questions. And one of them, for instance, is dynamic rule loading. What we find in customer installs is that typically, as MSP, as I said, we're dealing with like a lot of different sensors out in the field. It's fairly common that despite how well we try to communicate with people, that if they change out something, it's kind of important. So for instance, if they decide to go from Cisco ASAs to Juniper firewalls, that's actually a big deal to us because we need to know that that switch occurred. So we have this concept of called dynamically loading. So what happens here is this is in the Sagan YAML file. We can enable it and we set a sample rate. And remember, we're dealing with logs here. So what we're basically saying here is on the 100th log that you receive, we're going to pass it to a different type of rule set known as a dynamic rule set. And then the last option is the type, which says dynamic load. The other one is log only. What this basically means is I saw some traffic that I didn't expect, and it just logs it. Dynamic load means I'm going to load it for you. So we actually use the exact same engine that we use from the detection side of things. So for instance, just like you're writing rules to identify possibly malicious activity that's happening in your network through log analysis, we actually use the same engine for dynamic rules. And so in this particular case, this rule is very simple. You'll notice there's no content in here because we have the program field. The program field just says, it looks for any kind of software that's related to rsync in this particular case. But there's this other part right here which says dynamic load, and what it's saying is if it's enabled, I want you to load this rule set whenever you detect this type of log activity. So the idea here is we have you go in and you set up Sagan and you've got it up and you turn on the rules that you want to. With the dynamic loading, we have quite a list of things for it to watch for. It'll look and say, do I see any other indicators of something that may not be turned on? So for instance, let's say it's Oracle logs, and it comes across an Oracle log and it says, wait a minute, Oracle logs aren't loaded here. So what I'm going to do is dynamically load it, and it automatically loads it. It automatically loads it for that run and creates an alert. It drops some Eve output and to tell our SOC, hey, you need to go here and modify the config and load this manually. But for the time being, it'll get it working. And this is another type of example. So this actually is Oracle. So what we're looking for is, and the content is something that looks similar to what we'd expect to find within an Oracle log. And again, that sample rate, as I said, is usually set to about 100, but that's dynamic. So the idea here is if the lower you set the dynamic rate, sample rate, the more CPU that you're going to use, but it'll take less time to detect new things that have come in that are logging in your network. But the larger it is, the longer it's going to take for it to detect those things. So you try to find a trade-off there. We also do something similar, but in the opposite direction, where we want to identify what rules are loaded but aren't being used. So again, in the Sagan YAML, what we add in is a rule tracking option. We enable it. The console part that says display it to the console if you're running Sagan in the foreground, if you're watching statistics and whatnot. And then we also want to be able to dump it out to syslog. And then a time in minutes, how often do you want this to report to be generated? So what happens is every several hours or whatnot, it'll dump to syslog on all the rule sets that have been fired. The idea here is that then we can go through, or you can go through and say, okay, these rules have been firing, but these IPOP3D rules probably are something that maybe I don't need. Or the Windows.rule set is actually depreciated. There's no rules in there in the first place that shouldn't even be loaded. So that you can go through and identify. So we're trying to help out with some of the concepts of making sure that the proper things are loaded, and then making sure that the things that don't need to be loaded can be safely turned off. Now, so as I said, we track and use SuriCata in our environment and really love it. So it's made sense to us to adopt more output formats. Sagan does things like, for instance, your fast log, alert log, stuff like that, and it'll do things like unified too, which don't use because it's not very flexible. However, the Eve output is very, very flexible. So we've adopted, for instance, things like Eve output. And again, what we're trying to do in many cases in our operation is take the IDS data, the packet data that we're receiving from SuriCata, and then sometimes even trying to cross-reference it with the log data that we receive. So this makes it kind of an important feature. This is, for instance, something that Sagan has created. So it's created this particular Eve. It'll look exactly the same. This also means that you can slurp this stuff up using Logstash or whatever your favorite backend to get into your Elasticsearch or whatnot. You can slurp this stuff up and suck it into your backend just like you would if it were a Suricata log. But in this particular case, it would be based off of log analysis. We want to get the data as best as we can for our operations as a security operations center with so many different things out in the field to not have 10 different panes of glass for our analysts to have to go through. We want to give as much the data to them in one place or as few places as humanly possible. And this kind of allows that. So you can do things like load up EveBox, for instance. That's what this is an older version of EveBox, and then have Sagan data stream directly into it. You can also have, if you're a Snorby user or Squeal or whatever front end that you like, we're pretty much front end agnostic. We don't really care about that. So we want to give this data to you in the format that you find best for your operations. And if you haven't noticed a theme, we piggyback a lot on top of other technologies, and we do that for a reason, for, as I said, training purposes, so that we don't have to retrain our SOC on how to write rules and whatnot. But the same thing for our backend, so we don't have to keep developing brand new backends all the time. And this one is another one, so just kind of showing you how it'll look like on the payload or whatnot. So Sagan can do quite a few things. Let me see how I'm doing on time. It's multi-tenant. We can do some interesting things like sniffing logs off the wire using libpcap and whatnot, dynamic rule loading, and a bunch of different features like that. One thing that's also a plus about coming to these conferences, so I'm hearing things like about the Dragonfly machine learning engine. And whenever I hear that, I talk to the guys and they're like, yeah, we suck into Eve. Well, see, that's what I'm saying. We use Eve, so we can piggyback on top of that possibly. Things of that nature or whatnot. So there's a lot of different options that you can use with Sagan, from everything from emailing you alerts to what you would suspect. But we do a lot of interesting things, as I said, tying information together. When we talk about Sagan, we always see Sagan as more of like a glue between systems. So I have a Cisco ASA log and a Windows log. How can I glue them together? Or kind of like middleware for that kind of thing.